Now let's take a look at something more like a RPG, role-playing game, or RTS, real-time strategy game type of camera setup. These both share a lot of similar approaches, and to some degree, a lot of the RTS stuff is looking a lot like a lot of casual games today and a lot of mobile stuff. So I think this is a really good starting point for a lot of those types of games. So let's take a look. What I've got here is simple plane and about 7 cubes I've set up just so we have something to look at as reference, and a camera. And I've taken the camera and pointed it down its z-axis, meaning it's looking, as you can see through the preview, straight down in a 90 degree on the X rotation, pointing straight down here. And if we play the scene, I've set up the W, A, S, and D keys to allow me to move forward, backward, left, and right. So I can move around the scene like this, you'd expect. So that's pretty cool. I've also set up the Q and E keys so that I can rotate my view left and right. And I've got the R key set up so that at any point I can press R and snap back to a 0 rotation. And you can see right here the rotation I'm doing around the Y-axis. And once again, R, we'll snap that up to 0. And finally, I'm using the mouse wheel to zoom in and to zoom out. So that's roll the mouse wheel forward, gives me a zoom in. And I've got it set to a pretty slow, granular thing right now. You can adjust the speed. And a pull back, which is a little faster. And I've got it clamped, so it only goes back to, as you can see right here, a value of 20 in the Y. As I go forward, it will stop at a value of 2. And that way, I'm not using any physics collision or anything on the camera. I'm just using that simple number. So it doesn't have the overhead of that, but it also doesn't let the player like cruise right through a cube or a player or whatever else you've got in your game. Let's stop this and take a look at how I set all that up. Starting with the move, what I did is put everything on this main camera. I've got several FSMs. I've got 4 of them here I set up, all set on the same main camera, and they handle all of the activity we see. So let's start off by looking at the FSM move, and you can name these anything you want. I like to leave FSM. It's named what it is, and then I put an underscore in whatever the function of it is. If I just have one FSM on an object, I'll leave it FSM, because then a lot of these default boxes work easier for me. But otherwise, FSM move, FSM rotate, zoom, so on and so forth. That's my naming scheme. This is really simple. All of the moving, up, down, left, and right, is done with one state in one FSM. Pretty cool. If you look over here, I've got a get axis vector, getting the XZ vector, which is mapping to the world XZ, right? Like so. And I'm just storing it in a vector called camera move. And I've set up that vector variable right here. It's local. And then I instantly do a translation. And if you look, a vector, camera move. So all I'm doing is using getAxisVector to find out what the input devices are moving me around in, and then applying it here on this vector to a translate. And I'm using it on the owner because it is on the camera, so that's what it's going to move. And I've made sure to set the camera in world space and not self space or local space because, as you remember, I've rotated it and it's facing down. So if I were moving it if I'm moving the camera and tilting and rotating it, I'm going to get bizarre results as I'm trying to move it. And I want the movement to always be left, right, up, down with the plane of the game, not with the camera. That's why I've chosen that. You may want to adjust this differently depending on what you're after. And I do it per second, so I get a nice, smooth, regular, not just once, but a regular application over time. And that's it. That is all it really takes to do this. One other thing to mention, I did put a multiplier on here of 10. Look at the default speed, it's really slow. You can use a multiplier to set the speed that you want your camera to move at. And it would move really fast. For instance, if it were 30, if it were 30, then, now I've got this really fast camera that's too much. You can set that to whatever you need in your game. Obviously, you want it faster if you've got a bigger map, things like that. And this also can be a variable itself. you can adjust that over time based upon distance. You can make the multiplier faster as the camera's farther away and slower when it's close. Whatever you need to do, that is a value there and where you can get access to it. Let's look now at rotate. This one's a little more complex, but it's not too bad. It's no tougher than anything else we've seen in any of my series. What I do here is just have a listener, and it's looking for 3 keys. It's looking for a Q. Whoa, sorry. That's off the screen. Let me scroll that up. So it's looking for a Q. It's looking for an E. That is a giant list because it lists every possible key you could touch as an option. So I picked Q and E for rotate left and right, and R for the reset. And I've got these 3 events, which again, you set up events right here. Rotate, reset, right, left, so on. And I've got them in right here for left, right, and reset. If I press Q, it fires off the left event, E presses off the right event, and R presses off the reset event. And each of those leads to its own state. And in these states, the first thing I do is look for the same key that led you here. For instance, if I use Q to send the rotate left, then the first thing I do in the rotate left state is look for another Q on a key up, which means if you stop pressing Q, if we get an event that says the Q key has gone up, then quit doing this and use the rotate stop, which sends us back to wait. So that's how you set how you're going to get back and forth between Q, E, and R, or whatever keys you choose. So first thing you do is see whether or not you should bail out of this and go back to the wait state. If not, if that hasn't been lifted, it means the key is still depressed, in which case I just use a very simple rotate action right here, and I apply it to the owner, and I'm rotating around the Z angle, which is the camera Z, as you remember. That Z is the blue, so I'm rotating in this, like a clock. So it's clockwise left and right is really what's going on there. And I've set it to 0.3 every frame. And you may want to do this per second. It's entirely up to you and based upon performance and how you want things to handle. And I'm rotating it around its own space, not world space. Rotating around world space would have a different result where instead of the camera turning itself really tight, you might get a thing where the camera might physically move around, like a world space or some other point you've set. So it's an important distinction, again, if you want the camera to rotate itself or around something else. And the right is the same. I just rotate in a negative direction, and I look for the E key instead of the Q. Otherwise, exactly the same. And the reset, I don't look for a key up. It's just a simple press of the R will activate this, and it'll happen instantly and come back. So there's no need to do every frame. And this is just a simple reset the rotation on a 0. So there you go. And that's all it takes, those 3 little states, to get this sort of behavior for your rotation. All right, let's take a look now at the zoom. So the zoom requires 2 different FSMs. The first one is very easy. It is a 1-state FSM, and I call it get wheel zoom because that's all it does. I use a get axis function and enter mouse scroll wheel for the axis name and store it in a global variable called mouse zoom. So what this is doing when you ask for the axis mouse scroll wheel, it gets what the mouse wheel is doing. It just figures out what's happening. And what you get is a value of 0.1 if you're pushing in one direction and negative 0.1 if you're pulling in another direction. So it's really just saying going this way, going that way. There's not a big rolling number like, it's at 0, and if you roll it forward for a second, it goes to 40, and if you roll it forward for another second, it goes to 80. It doesn't work like that. It's either applying a 0.1 or applying a negative 0.1 is the result you're going to get back from this. And if you have any question ever when you're doing something like this, what you get, just output this to a GUI text object and see what value it's getting you. And it'll be really, really handy. I take that and store it in a global variable right there, and then we can use that number somewhere else. I set up that somewhere else as an FSM zoom. I do a setup where I set the camera zoom position, which is another global variable. I set it to 10, just to make sure it gets reset every time I start this up. And then I set the position of the main camera on its y-axis to camera zoom position. It's currently sitting at 10 in the scene right now, but what this does is snap the camera to exactly this spot. And then all of this wiring knows where relative to start, which is at 10. And 10 is right in between my two clamp values of 2 and 20, if you remember. So that's it. It does this once on setup, and then it goes into this listening state of applying zoom. And I use a float compare, and I look for that mouse zoom, which remember we applied that back here on FSM zoom get, mouse zoom global variable. This FSM in this state is listening for mouse movement. And that is going to be, if you remember, a positive 0.1 or a negative 0.1. I search for 0, I compare this to 0, and if it's greater than, I zoom in right here, and if it's less than, I do a zoom out event. So pretty binary. It's like do nothing if the mouse wheel is doing nothing, or zoom in or zoom out. And I check that every frame because you need to, otherwise it'll check once and never again, and then your zoom will not work. Let me walk through this. I do a float compare for when we get to a zoom in or zoom out. They're both exactly the same, other than numbers, whether they go positive or negative. But I do a float compare right away to mouse zoom, the same number, and I do the same thing again. Is it 0? And if it's equal to 0 or less than, just as safety, then I stop zooming and I go back to this. So in other words, if the wheel stops moving, go back. Don't do this. That's just one of many ways you can capture that and take action on it. Float operator then. I take the camera zoom position, which is where the camera is sitting in space, and I apply a 0.3 to it every frame, but I subtract it. I don't add it. I subtract a 0.3 every frame, and then I store it back on itself. So I just adjust this one number. Then I do a float clamp on that same number and clamp it to a minimum and a maximum of 20. And that means that's what's going on right here. When you look and I zoom in, I hit this spot, it's at 2. That's the minimum number. And I'm still rolling the mouse wheel forward and nothing happens. That keeps me from going through the floor or through the cube or anything else. And it's important that you apply this after you do the float operator, because you'll push the wheel forward, it'll get to 2 and then stop, and then you'll push the wheel forward again and it will now take this value, which is 2, subtract 0.3, which will make it 1.7, and then it will run this clamp again and clamp it back to 2. And all that happens before set position. So you want this to happen in between the operation and in between that. If you put it somewhere else, you still may move the camera in ways you don't want. Make sure you get it in that order. Then I do a simple set position, and every frame, because we're doing all of this every frame down the line, I set the camera zoom position on the y-axis of the camera, because it's the y-axis that goes up and down. And I do it in its own space, not in world space. And that happens every frame, and there we go. That's how we move the camera. This way, I do it exactly backwards. Still in the Y, I still do a float clamp, 2 to 20. I still do the operator, but I add this time. And I'm doing a 0.5 to zoom out and a 0.3 to zoom in, just so it zooms a little faster out. These are totally tunable to you. And that's it. That's how I do the zooming in and out. Pretty easy setup, really. And you can control these different values from a lot of different things. You don't have to use, for instance, the WASD. You don't have to use that for this. You could use a mouse movement. Like in the previous example, we clicked on an object and the camera would look at it. You could set this up to, when you click on the object, instead of looking at it, it could use those same coordinates and apply that move to it. So you could click on an object and move down to where it is instead. You can control these in any way. The important thing is to know, and see, just here's some basic ways to move stuff around with the camera and apply a lot of those things we learned earlier about camera frame offsets and tracking targets and you can do a pretty neat complex camera system just from these starting points. So that is an RTS and RPG style camera basic setup.